This car moves in total silence, with no smoke, no engine noise, and no gasoline at all. Hidden beneath the floor lies a 600-kilogram technological heart that makes this silence possible. To build a cleaner future, we first dig deep into the earth for rare minerals. Lithium, nickel, and cobalt are extracted from rocks that look completely ordinary. All these materials travel thousands of kilometers to reach a single place. This is where the heart of every electric car is born, inside a giant factory. Lithium is often harvested from vast salt deserts where water evaporates for months. In other regions, gigantic machines extract hard rock from deep, open-pit mines. These rough stones contain the essential elements that will store electrical energy. Before entering the factory, the minerals are transformed into ultra-pure chemical compounds. Inside large mixers, dark powders are blended with extreme precision and care. Everything starts here as a carefully engineered chemical paste called slurry. Ultra-thin copper and aluminum foils unwind like metallic ribbons across the machines. The chemical slurry is coated onto the foil in layers thinner than a hair. The coated sheets travel slowly through a long, heated tunnel to dry perfectly. Heavy steel rollers compress the material to reach an exact microscopic density. High-speed blades slice the sheets into narrow strips with millimeter precision. These finished rolls of electrodes are now ready for the most sensitive stage. Workers enter an airlock where the air is drier than in the Sahara Desert. Digital sensors constantly monitor humidity levels close to absolute zero. Here, robots assemble layers of electrodes and separators with surgical precision. The layers are tightly rolled together into a structure called a jelly roll. Laser beams weld tiny metal tabs to create perfect electrical connections. The cell is sealed inside a metal casing, isolated from the outside world forever. A precise amount of liquid electrolyte is injected deep inside each sealed cell. Automated machines immediately close the top, making the cell permanently airtight. For the first time, electricity flows inside as hundreds of cells charge together. The cells then rest for days in warm rooms to stabilize their internal chemistry. X-ray machines inspect the inside structure to detect invisible defects. only the cells that meet strict performance standards continue the journey. Hundreds of identical cells are placed into a perfectly aligned metal grid. Robotic lasers weld metal connectors to link every cell into one network. A cooling plate is installed to remove heat during intense battery use. Tiny sensors and wires are added to monitor temperature and voltage continuously. An aluminum frame closes around the structure to protect the entire assembly. A barcode is scanned, giving this module a digital identity for life. A large aluminum structure waits to receive the finished battery modules. Robotic cranes slowly lower each heavy module into its precise position. Bright, orange, high-voltage cables connect the modules into a powerful system. A thick sealing gasket is placed to protect the pack from water and dust. Pressure machines check the entire pack to ensure it is perfectly airtight. The heavy lid is tightened, sealing one of the most powerful batteries ever built. Engineers drive a steel nail through a cell to simulate an internal short circuit. A hydraulic press slowly crushes a module to reproduce a severe accident. Inside a fireproof chamber, a battery is forced into thermal runaway. The entire pack is dropped from height to test its resistance to shocks. In a control room, engineers analyze thousands of live data points. Only batteries that survive all these tests are allowed to leave the factory. Across the world, millions of electric cars now rely on batteries like these. The same technology is used to store solar and wind energy for cities. Used battery packs arrive at recycling centers for a complete transformation. Powerful shredders break them down into small, reusable fragments. Chemical processes extract lithium, nickel, and cobalt from the crushed material. This global industry is reshaping supply chains and international geopolitics. Researchers are developing solid-state batteries without any liquid inside. Some new designs may replace lithium with more abundant materials like sodium. Around the world, new gigafactories are being built at incredible speed. Engineers constantly test lighter, safer, and more efficient battery prototypes. Every sunrise over these factories marks progress toward a new energy era. And it all begins here, inside a Gigafactory where the future is assembled.